So this is just a warm-up. It says, Sari realizes that she's going to make 12 calls to 12 stores. She sells 60 boxes per store. So if she goes to 12 different stores, she would sell 60 boxes per store, which means she'd sell a total of 720, I think. Okay. Every time she makes an additional sales call, the number of boxes decreases by 3 per store. So what would this go down to? This would go down to 57 if she goes to an additional store, it says, right? Okay, so anybody want to do that for me? What's 13 times 57? Thank you. All right, so it's still going up. At some point, if she goes to too many stores and this continues to go down, she'll be in trouble, right? So what we want to do is write an algebraic expression for this and an algebraic expression for this, and then we want to maximize that. What are we going to use x to represent? Anybody remember? Yes, number of additional stores that she goes to, or just number of changes we're going to make. We don't want to call it just the number of stores because we already know we're starting somewhere. Okay, so I would use the starting point of 12, and this one's doing what? Going up one at a time though, right? Not 2 at a time, not 3 at a time. It's going up by ones. What is this doing? Yes, starting at 60 and going down by 3. Everybody okay? All right. Can you try on your calculator to find a maximum for that? What might be an appropriate window? Yeah, this is going to be pretty high, right? Because this was 720, so we might try 1,000. X, how many times can X go down by 3s before we'd run out? Yeah, 60 minus 3 times 20. So this can't be more than 20. It's probably considerably less than 20, but there's an okay window to try. Hello, where's my low? There we go. Or not. What was it, guys? 60 minus 3x? Okay, so window, we said maybe 0 to 20 and 0 to 1,000. What are we looking for in this window somewhere? A max. Does it look like this has a maximum in this window? Okay, so we're going to go 4. I'm just going to type in that it's somewhere between 0 and 20. I got a maximum at 4. This is calculator error. Some of you probably got exactly 4. Okay. So if x equals 4 is where the maximum occurs, how many stores should she visit? We're supposed to find the number of stores. Yes, she shouldn't visit 4, right? She should visit 4 additional stores. So 16 stores. And honestly, the number of boxes she would sell at that is 768 because that's where the maximum Y value is, okay? And you would, this is all it's going to ask for on the quiz. And I did give you a hint right next to the line I wrote total stores to visit or whatever. It's not actually stores on the quiz, but all right. Did anybody want to take a picture because they wanted extra practice on this or no? We're good? All right. So today's lesson, we're going to talk about evaluating a function at a value. We're going to talk about determining If something is a function, we're going to talk a little bit about domain and range. I will tell you, when we put the learning targets together, which you don't have the learning target sheet yet, that's because what I did is I put one, actually, Ms. Abruzzo, put one together for next week's quiz with just the targets that are going to be on that quiz. So we're going to try to do it that way, like show you what you need to study for the quiz rather than the whole list of the chapter. And that'll include ones that you need to go back and study because we're putting them back on again. All right. I will tell you, like, not all of this is necessarily only in 1.1. We had to kind of lump some topics together in this chapter. So, all right. We're going to start by just reviewing really quickly the set of real numbers, all of the subsets. Anybody know what rational means? What is a ratio? Like if we did boys to girls in this class, it's like, I don't know, 12 to 5 or something. Okay? Not, but it's close. It is a relationship of one number to another, right? So it's anything that can be written as a fraction, anything that can be written as a ratio of two numbers. So that would include whole numbers, yes? Because we could write 12 over 1. It would include fractions. It would include decimals that terminate, even decimals that repeat, 2/3, right? It's a fraction. It's a decimal, 0.6666. Okay, what are the only things that fall in irrational then? Well, who's irrational in this room? Maybe. Irrational means a little crazy, right? So what kind of crazy numbers? Pi, E. Talk about E, that one? I is imaginary. That's a whole, it's not even in the reals, okay? Reals means we don't have any I's. Irrational also includes things like square root of 7. Did you ever look at square root of 7 and realize it doesn't ever repeat or end or anything? Okay. Those are irrational numbers. Okay. It's not irrational if it can be written as a fraction, which means that any decimal that ends or repeats is rational. Integers are just the positive and negative whole numbers. Just includes negatives. Okay. Natural or whole numbers are like 0, 1, 2, 3, 4. And natural, I like to say, natural numbers is when Mama taught you to count. Did she tell you to start with 0? No. When she taught you to count, naturally you start with just 1, 2, 3, right? Mama taught you to count with 0. She actually started at -1,000,000 and counted up, right? All right. This is a nice graphic I found. Does this make sense, guys? Irrationals are those crazy numbers. That's supposed to be a pi symbol, I think. Rational is all this kind of stuff. It would include, though. Do you see that inside of the rationals are all these as well? Okay. Integers can be negative, but they also include all of these numbers. Whole numbers, the only thing isn't included in naturals is 0. Does that help somebody understand what we're talking about here? Okay. As far as I know, we're not putting this on a test or quiz. It used to be on a test or quiz, and people did really horrible. It would say, it would give you a number and say, check all the boxes that it's true for, and they'd just check away. All right. This is what your book has for examples. And again, it shows the same kind of graphic, but they use weird letters that just blow my mind. Okay. When we start talking about a subset of numbers, the book will use what it calls set builder notation. I hate it, okay? But I want you to see it because it's in the back of the book as it answers. When you look up the odd numbered answers, they will use set builder notation. We are going to use interval notation. Do you remember interval notation? Okay. Set builder notation, you choose a variable, you list the properties of the variables, and then you tell which set of numbers it belongs to. They use this on standardized tests as well. So I'm going to expose you to it, but we are going to answer with interval. With interval notation, you use brackets if something is included and parentheses if it's not included. Do you remember that? And you use infinity to represent infinitely big numbers and negative infinity to represent infinitely negative numbers. Now, you always use parentheses when you use infinity because it doesn't include infinity because it just goes on. Okay. So here's an example of that weird set builder notation. If we wanted to write x is greater than 18, they would write it like this. And that reads x such that x is greater than 18, where x is an element of the real numbers. Do you want to have to write that? I'm kind of going with 18 and up to infinity. Okay? But I just want you to know when you see this in the back of the book, this is what I'm expecting you to write, but do you see a relationship there at least so you understand kind of what that means? Remember, my answer keys are always over there, and I answered in interval notation, okay? So here's one. It says x such that x is between -3 and 16 and can include both ends, where x is an element of a given set of numbers. I don't even remember what z stood for. Do you? Integers? Okay. I hate that notation. Okay. No. If they use it on a standardized test in a question, you just need to understand what it means. No, you're not going to have to answer that way. Okay. This is what you're used to, yes? If it's between A and B including, you put square brackets. If it's not included, then you put round brackets, parentheses. I like to call these hard brackets and soft brackets. Did you ever have a teacher that did that? Okay. So this one has a including on the A and not including on the B, etc. If it's unbounded, it's called, goes on forever in one direction or the other, then we use all this good stuff. The big thing is when you write them, the numbers must always go least to greatest. Does that sound familiar? So if you wanted to describe this picture, you had 8 going that way on a number line. You can't say 8 to negative infinity. Oh, that was not an infinity. Forgot to stand on my head when I drew it. 8 to negative infinity. You have to write it negative infinity to 8. Does everybody get what I'm saying? It's got to be like left to right on a number line. All right, moving on. So can we practice just real quick? Who can tell me number 1? If you picture a number line, it would be a solid circle at -2 going this way. So how do we describe that with interval notation? -2 and a hard bracket, yes. And remember, with any kind of infinity, it's a parenthesis. What about number 2? Normal parenthesis. What's with the 8s and the infinities? That just makes me... Yeah, because I can't... My 8s look like infinities and my infinities look like 8s then. Everybody okay? What about 3? 5 to 15 in regular parentheses. Whoa, 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 that's a parenthesis. What would make them square? If we had put under here some equal signs, then it would have looked like this, right? How do I know this is not an ordered pair? I don't. It depends on the situation, what it's there for, okay? It's got to be clear in context. All right, this helps me if I think about the number line. This is open circle going this way, solid circle going this way. Remember these? Got to use a U? Okay, how do you describe this left one? Good. Okay. Anybody in here this is uncomfortable? You did not do a lot of this before? Okay. Sometimes I get a transfer student who doesn't know, and then it's painful for a while. All right. Function versus relation. A relation is a rule that relates or pairs the elements of a set A with elements in set B. Set A is the input or the domain. Set B is the output or the range. A function, okay, from set A to set B is a relation that assigns to each element in X of X in set A exactly one element in B. So the X's can't repeat. Does that sound familiar? Repeat or be used more than once to be for a function. All right, so generally the domain, which value? X. Well, the Y, whoops. The range represents the Y value. I can read. I just skipped over that word range and I got confused. Anybody know which is independent and which is dependent? Yes, X is independent, Y is dependent. As the output is the Y, right? So it's depending on what we put in for X. How I remember it anyway. Okay. So this is an example of function because all of these X values or inputs are going to exactly one Y value. So it doesn't matter that 2 goes to 8 and 3 goes to 8. The Y's can repeat, but not the X's. Miss Abruzzo has a cute little story about, every girl can like more than one boy, but boys can only date one girl or something, and I just get all confused. So, did she tell you something like that? Okay. Oh. All right, guys. I don't know. Do I have this open already? I thought I did. All right. I thought I had this open already. There's a cute little, when you have a graph, how do you tell if something's a function? Vertical line test. And your book happens to have a cute little video. It's like 47 seconds, but I thought it covered it very well. So I was going to show the video. Oh no, it's maybe. Okay, guys, has sound.
Not included for the upper portion of the graph. The vertical line never intersects the graph at more than one point, so this graph is a function.
Did you get that last one, or do we need to go back over that last one? Because one is hollow and one is solid? Okay. So we're used to the vertical line test. We're good with that? Just entertaining you there with a little video. Okay. So here's my examples, I think, right? Is this where we are? What do you have? Oh, you don't have this. Okay. You just look up here. Is this one a function? All you need to look at is the x's, right? If they don't repeat, it's a function. Is this a function? Nope. There fails the vertical line test. When I put in apparently a 6, I get out both a 1.5 and a negative 1.5, right? Right. Not a function. All right, what about this? If you were to solve for the y, You'd add the 2x over and square root, but because of the plus or minus, if I put in, say, 2, would that work? 2 times 2 would be 4, plus 5 would be 9. Square root of 9 is plus or minus 3. So I put in a 2, I get out a 3 or a negative 3. It actually looks like this. It's 2 square root graphs, okay? So when y is squared, means we can have a plus or minus. So the same x value will give us 2 y's. A little bit tricky from that. But the other thing that's tricky is you can't just type that on your calculator and graph it easily, right? Because your calculator wants y equals function form. All right, here's an application. Determine whether this would be a function. If the input is a student's ID number and the output is their score on one particular physics test, every student who took the test, right, is only going to have one score. Each student, one score. So yes, that would be a function. It was apparently prior to the retake policy. All right. So you have these examples. Can we draw for example 1A a graph of a function? What could we draw? A parabola, as long as it opens up or down. A line, any line, as long as it isn't vertical. We could draw a cubic, okay? Anything, as long as it doesn't cross the vertical line more than once. Draw a graph that's not a function. Somebody said C, sideways parabola would work. A sideways absolute value would work. A circle would work. A vertical line would work. Okay. Yep. All right. Example 2, I think I actually have on another slide. Okay. Find each value. Function notation. You remember this, right? What does A mean to do? Put a -4 in for all the x values. Be sure to type carefully. When do you need parentheses? Yeah, you could just always put it in parentheses, but the one that will give you the wrong answer if you don't is this particular one here because you're squaring a negative. But I would just put it in anytime there's an exponent here and you're using a negative. I don't know, guys. 128, 256. I'm going to take your word for it. All right, what are we supposed to do for the second one? We're supposed to put a 2a in. So what will I write down? 4. 2a quantity squared plus, oh, it's cubed, just kidding. 6 times 2a squared plus 3 times 2a. Now, it's pre-calc. So guess what? We need to simplify that mess. So what's 2a to the third? Right, 2 to the third is 8, and an a to the third. Okay. Back here we have a 6. The 2 is squared, and the a is squared. And back here we just get a 6a. All right, so I'm getting 32a cubed plus 24a squared plus 6a, which is 52a cubed, you think? No, please stop, right? We can't add unlike terms. Just checking. See if you're awake. All right. Guys, you need to you need to simplify. The only exception would be, I think there might be one like this on the homework. If you end up with something like this, If it has a cubic here, you can just leave it, okay? If it's a squared, I want you to do it, and we're going to practice that. That's what's on the quiz, is a squared only, like this part of the question, okay? But if it has a cubed with some disgusting, you can just leave it. I'll go with, let's not waste our time, okay? Evaluating piecewise function. Actually, piecewise is going to be a whole separate category on a quiz eventually. You're going to have to graph them, but for today, all I want to know is evaluating. If I put a 1, which rule does a positive 1 go into? It says x is less than 4, then you use this rule, right? Do you remember this now? If x is between 4 and 10, you use this rule, not including 4 or 10. If x is greater than 10, you use this rule. Now you remember what a piecewise is? Okay, so a 1 is less than 4, so I put it in the top rule. Square root of 1 plus 1 would be what? 1 plus 1 is 2. We good? If I have a 3, which rule does it go into? The first one. Square root of 3 plus 1. I guess you could give me a decimal, but it doesn't simplify, right? No. It's not 1 times the square root of 3. It's the square root of 3 plus 1. So you could leave it. You could write 1 plus the square root of 3 in the other order. I'm guessing 2.6. How'd I do? 2.7? Okay, I fail. All right, 6. Which rule does 6 go into? 6 falls between 4 and 10, so we have to do 3 times 6, which is 18. And then what about 10? 10, this one did not include 10. This one includes 10. So we go 2 times 10 squared minus 15. Somebody's going to do 20 squared in their head and do this wrong. Why is that wrong? Exponents first, right? So this is 2 times 100 minus 15, or you can use your calculator. 185, how did I do? Okay. All right, more fun with functions. Can you try these 3? You do need to answer this one in simplified form. Anybody willing to come up and put an answer for any of them? Pick A, run, do A. Go ahead, Michael. What do you think, guys? Anybody want to cry a little? Michael, can you go back up there? What's -1 times -1? Right. And if you type it the way you did, you got to put that -1, the first -1 there in parentheses, or it'll do it wrong. But thank you for modeling the mistake everyone will make. So this one needed to be in parentheses as well, and then it comes out what, guys? 10. Okay. He was just kidding. He wanted to see if he could catch that. Who's got B? Now that I've scared you. What do you have? Oh, go ahead, Andrew. Copy it up. I don't care. You can just put it down, and then we'll see if we agree or not. Oh. I don't know what we did. Oh, you're good. Agree or disagree? Okay. I don't have any problems with that one. Anybody want to try C? Take your time, but I need you to finish and simplify that one. Who's got it? Go ahead. Thank you. What's on your socks, kitties? I'll trade you a math sock. No, I'm kidding. No, I had to keep my math socks. They were a Christmas present. I'm betting some of you have this one wrong. Oh, Madison. Nice, you fit that on there. I'm impressed. Madison got it right. How many of you had something else? Some of you had it right? Nobody's going to admit they had something else. Did anybody try to distribute the squared? That's usually what someone does. X plus 8 squared does not equal x squared plus 64. Okay, there's a meme of that on the backboard. It shows Batman and Robin, and Batman is slapping Robin upside the head. It says this. It says a plus b quantity squared does not equal a squared plus b squared. All right. Everybody better? It's below the kitten meme. The kitten one is my favorite. Okay. All right, guys, what about this? Can you do this one on your own? Put a 3 in and an 8.5 in. Oh, the 3 is tricky, I heard. Is the 3 tricky? Which rule does the 3 go into? Because it's or equal to, it goes into this one. 2 times 3 plus 10 is 16. Okay. 8.5. 8.5 goes in here, but then what do we do with it? It's just 42. Don't say it's stupid. If you had to graph it, it'd be your favorite kind, because all you'd have to do is draw a horizontal line at 42. Okay. Decide whether this is a function, guys. The input X is a car's license plate number, and the output Y is the car's make and model. So can this repeat? Do more than one car have the same license plate number? Not within a state, right? If you were talking about within Illinois, okay? There wouldn't be the same license plate number issued to more than one person. So even though there can be more than one license plate that matches the make and model, okay, more than one Dodge Caravan out there with different license plates, that doesn't matter. The X, the license plate number didn't repeat. So this would be okay. What about this one? What is that? Somebody said it. It's a sine. It's some kind of a sine curve. What about 9? Nope. That's something like an absolute value of y equals x. Okay. All right, guys, when you're given a function with an unspecified domain, the implied domain is the set of all real numbers for which the expression will give you a real answer. In general, you must exclude values from the domain of a function that would result in division by 0 or taking the even root of a negative number. Okay. Students get so freaked out about domain restrictions. This is all you need to know. All you need to know. The denominator can't equal 0. And if there's a radical, like a square root or a fourth root, you can't square root unless what's under it is greater than or equal to 0. That's it. Everything else is all real numbers for the domain. Don't make it harder than it is, okay? It says it's only restricted by a radical or an x in the denominator. The denominator can't equal 0, and what's under the radical must be greater than or equal to 0. Otherwise, it's all real numbers. If it's not a function, then it gets a little bit trickier, but we're not going to do those. So, why is this one a little tricky? Because it has x in the denominator, yes? What can we do to that denominator? How can we simplify it? If we take out an x, can we throw that x away? We can't, this is just simplifying a fraction. It's not an equation. We can't do anything with it, so we can't throw any part of it away. But now we have two things multiplied in the denominator, and neither one of them can equal 0. So what are the restrictions on the domain? X cannot equal 0. Okay, it says the excluded values are x equals 0 or x equals 6. Now, if they were to write, honestly, on a quiz like this, I would probably let you write, if it didn't specify x cannot equal 0 or 6, where x is all real numbers except for 0 and 6 or something. Can you help me write it in interval notation? It's going to have some u's. Andrew? Everybody's okay that these parentheses mean up to 0 and then starting above 0. So like negative 0.0001, that still works. And on this side, positive 0.0001. Yes. Ariane. Because there is no ending value. So that's why. That's a good question, but that's the way I would think of it when they designed that concept. Because infinity goes on, they just said it's going to keep going. There's no end limit. All right, determine if each relation is a function and state the domain and range. Okay. What would this look like if I graphed it, guys? We could rearrange it, but bottom line is it's a line. Does it have a denominator or a radical? So the domain is, yes, all real numbers. What about the range? If you visualize a line that's doing something like this, I guess I'm backwards for you guys. What about range is bottom to top, remember? Is it going to end bottom to top? Nope. Okay. Linear functions, unless they're horizontal lines, have infinite domain and range, both. Okay, what about 11? It is a function. How do you find the domain? Yes, you could graph it. That's not a good answer because it's not going to find an exact value. What is the, guys, two things I said you have to know. The denominator can't equal 0, and what's under the radical has to be greater than or equal to 0. So if I write that, can you solve that? Be careful. What do you have to do that makes it tricky? So when you divide by a negative, you got to flip it around. Okay. Now how do we write it in interval notation? included. Because you can take a square root of 0. Anybody know what's going to come out without graphing it? When you square root, what kind of number do you always get out? Positive or 0. You can't get a negative unless there's i's in there, and then it's not in the real number system. So the range would be 0 to infinity. Now, the issue with graphing this on your calculator, it's going to look like this, I think. And the issue is finding this point where it ends. The x value is not, even if you can get it to say negative 0.66667, it's not going to give you the fraction, okay? That's the other way, yep. All right, so it's good to know how to do these without just graphing because you will not necessarily get them right if all you do is graph. What about this one? Not a function because the y is squared, okay? If we got this by itself, let's think about this. We divide, then we'd have to square root, and then we'd have to add the 1 over there. That's kind of gross. But it would have a plus or minus on the x, so it's not a function. I'm going to go with, then we don't want to do domain and range. What do you think? Okay, what about number 13? I don't want to do range on this. Because if you graph it, this is what you get. How would you type it in your calculator, first of all? If you had to graph this. You must have parentheses around the whole top and the whole bottom, yes? Okay, and I had a hard time finding a window that looked good, but it does have a gap along the range in here because there's some values that won't come out, okay? I don't care. I just want the domain. Tell me how to find the domain restrictions. Yes, factor the denominator. All right, guys. Here's what it's on the assignment sheets, guys. Did you just get an assignment sheet in the back of the room? There's only 1, 2, 3, 4, 5, 6, 7, 8, 9 problems on here, okay? If you finish this one, guys, x cannot equal 3 or 5. So you'd have something like this.